This lesson, we are going to introduce new concepts into a unit of periodic data and periodic functions. So to begin this, we're going to just simply look at what is a periodic function. As the name itself states, a periodic function is one that follows a period, a set amount of time or things occurring at regular intervals. Shown in the diagram is the graph of a periodic function. And the pieces of this graph are as follows. First, this section that's noted in blue is called a period. A period is the amount of time or the distance it takes for our function to complete one full cycle. It has to begin and end at the same y value headed in the same direction. So if we were to start a period here and follow it through, it would not terminate here. Even though it has the same output value, it is not headed in the same direction. So if we start here, the period would terminate here. This distance that is shown in red of one period being complete is also called a cycle. And the more cycles you have in a given distance, the shorter each period will be. Now with each period, you have some other characteristics. You will have a center line of values. And the center line is exactly at the midpoint between the maximum and the minimum. Our maximum value is here, and our minimum value is here. The equation of the center line will always be of the form y equals and then a constant number. So I'm just going to call it c. The distance from this center line to either of the extremes, the maximum or the minimum, is called the amplitude. So the amplitude is half of the range of our function. There's a lot of new terminology, a lot of items being placed in here all at once, so be sure that you are taking good notes and definitions of this. The center, cycle, period, extremes, maximum and minimum, and amplitude are all terms that we use to describe a periodic function. Being able to identify a periodic function can be sometimes a little bit tricky. So let's take a look at some and see if we can identify their parts. We're going to determine in each of these if it is a periodic function, and if so, we're going to name a cycle, meaning its domain, state the period, the amplitude, and the equation of the midline. So first, in this first graph, are we looking at a periodic function? Does it follow the exact same output values on a regular interval? And the answer to that question is yes. This is periodic. Since it is periodic, we need to come up with these other items. We need to name one cycle. So pick anywhere along this graph where it begins and ends at the same y value headed in the same direction. So we could say that a period or a cycle is from 0 to the value of 6. So that would be here, tracing along back up to there. That is one cycle. Next, our period. Our period is 6 units long. Because it goes from 0 to 6, that is 6 units. We could just as easily have said that it went from 4 to 10, which would give us another period of 6 units in length. What is the amplitude? Well, our maximum value appears to be 3, and our minimum value appears to be 0. Our amplitude is 1/2 this difference. So it's 1/2 of 3 minus 0, which is 1 and 1/2, or 1 5/10. And then what is the equation of the midline? The midline is that value right in between. So in this case, we're going to have a midline of y equals 1 5/10, or 1 1/2. That would be located right approximately here, and it's equal distance to the maximum or the minimum from that point. Let's take a look at the second graph that is shown. Is this periodic? Does it follow a repeated series of y values over time? And the answer again is yes, it is periodic. Since it is, let's find the other pieces. What is one cycle of this function? And we can take it from this value. Well, let's pick a different one. Let's take it from here to here. From the maximum back to the maximum. Our cycle goes from -2 to 2. That means that our period has a length of 4. 2 minus a -2 is equal to 4. Our amplitude is going to be 1/2 of the distance from the minimum to the maximum. Our minimum value is -1. Our maximum value is 2. So that'll be 2 minus a -1. That's a value of 3. Half of 3 is, again, 1 5/10, or 1 1/2. Now, the equation of our midline, we're going to take that amplitude value and add it to our minimum. So 1 1/2 plus a -1 is simply 5/10, or 1/2. So right about here is the midline from what the amplitude will be measured against. Let's take a look at a couple others. Again, we're looking at the same items. First graph, is this a periodic function? Does it follow a pattern in its work? The answer is yes. Do the y values repeat each other? And for that, this is no, it is not periodic. So we do not need to repeat or find the other values that were mentioned. Fourth graph, is this a periodic function? Does it follow a pattern? Yes. Does that pattern repeat y values? Yes, it does. So, once again, yes, this is periodic. Let's find one cycle. Cycle goes from here through all the way to here. So my cycle is going from 0 to 4. That means that my period has a length of 4. My amplitude will be 1/2 of the distance from minimum to maximum. Our minimum value is -2. Our maximum value is 1. So what is 1 minus a -2? Again, that's 3. This is coincidental. It's not always going to be that. But that means our amplitude has a value of 1 and 1/2. And our equation of the midline is y equals a -1/2. So being able to pick out these different characteristics of our periodic functions is going to be vital in our study of these functions. Now, once we have this down and are able to easily identify these pieces, how can we use this in a real-life application? Sound is produced by periodic changes in air pressure, creating what is called a sound wave. The yellow curve is a sound wave. The different lengths of the waves produce different pitches for our ears to pick up, and there's a limited range of waves that we can hear. There's a different range for waves that we can see. What is the period, amplitude, and equation of the center line of this sine wave? So let's take it. We know it to be periodic. The period itself goes from here at 0.005 and then will end here at 0.009. So that means our period, and this is in seconds, is 0.004 seconds. If a sound wave, or sound wave repeats itself every 4/1000ths of a second, it will always come out as being the same pitch for us. Next, what is the amplitude? The amplitude is the distance from the minimum to maximum. So our minimum is 1.5 and our maximum is 2.5. That difference cut in half will give us our amplitude. The difference is the difference is 1. 2.5 minus 1.5 is 1. So our amplitude is simply 1/2. And what is the equation of the center line? Our center is going to be located right down the middle between 2.5 and 1.5. It is the equation y equals 2. So being able to find these will produce different types of sounds, and like I said, if we change that period enough, it will change into waves that we can see. And scientists are able to determine different items based on the waves that are detected. So a lot of new vocabulary, a lot of terminology to look at here. Make sure you have them all down because this is going to start a fun new adventure for us.